Find all points of discontinuity of f where f of x is given by sin x by x for x less than 0 and x plus 1 if x is greater than or equal to 0. So sin as a function is continuous and x is also continuous. So the combination of that will also be continuous. Right? We can write it as a statement form. So first thing is we'll take up case by case. So c less than 0 and c belongs to R. Now we will look at limit f of x as x tends towards c. So this will be limit sin x by x as x tends towards c. So we can apply the limit to numerator and denominator. So this is to do with limit properties. I hope you guys remember this. Now, so this is sin x, sin c in this case by c. This is the property I was talking about. So we can apply limit to both numerator and denominator. The resultant of this will be the overall result. Now we have f of c. So for any value less than 0, the f of c will be sin c by c, which is same as limit f of x as x tends towards c. So it is continuous, right? So let me show this. I should have shown you guys the graph first. So we are looking at this particular wavy structure and then a straight line. So this wave structure is what we are doing now. So this is our sin x by x. So you can see it is continuous throughout. So it is continuous throughout. Why are the values what they are? You guys can think of it. It's not too hard. Now we will go on to the next part, that is onto the right side. So more than 0. So more than 0, we have the same behavior, that is it's continuous. So we have case x, in this case c, is greater than 0 and c belongs to R. So we have limit f of x as x tends towards c. It's an polynomial expression. So on substituting, we'll get, my bad, I skipped a step, limit x plus 1 extending towards c. So this is c plus 1, right? And we have f of c will also be c plus 1, and this is equal to your limit f of x as x tends towards c. So in both this region, the limit is continuous, as you can see. And what about 0, the point wherein we have the flip from the first function to the next function? Well, they too, as per the graph, it is continuing, but let's write it in with our algebra and arithmetic. So what do we have? First we have approach from the right hand side or left hand side. So c minus, on substitution, what we have is limit. So this is sin x by x as x tends towards, from the left hand side the behavior is, as you can see, sin x by x, and the graph also shows the same. Agree? And so this would be what? This is 1. I hope you guys remember this. Limit sin x by x as x tends to 0 is 1. Now we have limit x tending towards c plus from the right hand side, that is, so this 2 will result in 1. Here the expression is x plus 1. Sorry, this is 0. And so on substituting, this is 1. And finally f of c in this case f of 0, which is equal to, or let me do this, c plus 1, right? So f of 0 is 1. So finally, what can we infer? What is the question? Find all the point of discontinuity. We'll just write there is no point of discontinuity. There is, in the graph also, graph 2, it was very visible. There is no point of discontinuity. So that is our conclusion.